Hello everyone, welcome back to the lecture series of image processing and computer vision. Today I'm going to discuss the morphological image processing. In this, I'm going to cover the topic dilation and erosion, and also opening and closing. So before going to the morphological image processing, so if I give the document which is of the full of noise, or a image with the fingerprint with the full of noise, so how to remove the full of noise in the scan document? So where the morphological image processing is applied, which are the set of operations. Okay, and in this session I'm going to cover the main topics are dilation and erosion and opening and closing. Okay, now let's get started. So, morphological image processing. So, morphology. What does it mean? The morphology. Morphology. Logy means study. Morph means it is a term which is taken from the biology. It is deals with the animal shapes and structures, and plants names and structures. Okay. So, same thing we are using in the image processing, which is in the image processing where the image components are components acquired, getting the image components from the image. Okay, so the term which is deals with the shapes. Morphology means shapes. So the in the for extracting the image components from the image, so we are using the mathematical operations. The first is the set theory. Set theory is useful to extract the image components, even extract the some representation and description of the region shapes. Okay, and also boundaries, extraction and skeleton, convex hull, morphological filtering and thinning and pruning. Okay, these are some operations which is applied on the image to extract the description means features of the image, as well as a representation, how the image is represented in the how the objects are presented in the image. Okay, these are some mathematical morphology we are using. These are some mathematical operations which is applied on the image. So we'll see what are the operations basically used to remove the noise from the image. So these are the operations: erosion, dilation and opening and closing. So these are the four basic morphological operations together. Oh, we'll see one by one. Actual morphological image processing, where we can use the morphological image processing: image after segmentation. So segmentation means dividing the image into the subparts. So the morphological operations applied before the pre-processing of the input image segmentation, or you can apply the post-processing after output of the image segmentation. And also morphological operation used the image which consists of the noise. To remove the noise, you can use the morphological operations, uh, and also to detect the objects in the image. So that is the operations are useful to detect the objects also. These are some applications of morphological image processing. So what are the preliminaries to perform the those operations? So we need to learn the set theory. So what is the set theory? It is comes in the linear algebra. So for that we are using these two types of pixels. So first one is the objects and second one is the structuring elements. So object which is present in the image, and structuring elements are used to used in the to identify the objects. So which is we have in the image, we have the foreground as well as the background. Okay, to specify the foreground will represent as a 1, and background pixels as don't care are represented as a 0. And these are the some examples of structuring element. You can see structuring element can be, is there any shape, either it may be the circle or it may be the sphere, or you can see these here on the screen. You can see these are the some shapes of structuring elements. With the help of the structuring element, we'll identify the objects or shapes which is present in the image. So the name itself morphology. Morphology means shape. Shape which is present in the image. So to identify the shape in the image, we are using some structuring elements. If the structuring element is mapped with that object, then we'll identify those object which is present in the image. So these are the two important pixels we are using in the morphological operations. So, and also we'll learn the what some properties of set theory. Okay, you can see the screen. Set theory. A set is a collection of distinct objects. Okay, so each distinct object, and A is an element of set A. Then small a which belongs to small a which is belongs to capital A. A is a set and small a is the elements which is belongs to the A. And if it is a this A is not belongs to A, you can represent it. This is a representation of the A which is does not belongs to capital A. That is no elements are null or empty set, which is we can denote it as a pi. And also you can see a set is denoted by the contents. Okay, this is the representation of the set. And also C is equal to C is equal to minus D. You can C which is element C is equal to minus D, and D is belongs to capital D. Means what? Here is the set which consists of the elements which is multiplied by the minus 1. Okay, so these are the different ways of representing the sets. And also we have how the elements are belongs to capital A is belongs to the small b. Means what? Every element of the set A is also the element of set B. Then you can set to be the A is a subset of B. So this is a representation of A is subset of, means all elements of the A are also present in the elements of B. And also union means a set, two sets are A and B are union, means it's a together. All combination of the all elements of A and the elements of B. So C is equal to A union B. And also intersection. So there is no common element in the A and B. So common elements which is present in the A and B is called the intersection. Okay, and also A intersection B is equal to pi, which is a mutual exclusive. And also we have the complement of the set A. Complement of the set A is represented as a complement, which is equal to W, which is W here W, these elements which is not present in the set A. So then the complement of A is A complement is equal to W is the element such that W is not belongs to A. And also we have the difference of two sets A and B, which is denoted by A minus B. And A minus B means we are the elements only, we are taking the elements of A and not taking the elements of B. This is a complement, and this is the representation of the A minus B. Okay, so here the W is belongs to, means all elements of the W is belongs to A, and the elements which is not belongs to B. This is the representation of the A minus B, or A complement, A intersection B complement. Okay. And you can see here, so A is the one object, and this is the object A which is present in the image, and object B is present in the B image. So two sets A and B. So if I take the union of the, which will consider all the pixels of A and all the pixels of B. This is the, here we are using the set theory. With the help of the set theory, we are identifying the object which is present in the image. So for that, I am extracting the foreground image as well as the background image. So background, foreground where the important information is present in the image. Background is the some unimportant image. Simply we are escaping. We are don't care is applied on the background, and we are only taking the foreground image. So here is the A is a set. This is a set A and set B. So A union B means we are taking all the pixels of A and B. Here is the intersection is a common point between the set A and set B. And A complement here is A complement means what? We are not considering the pixels of A, not of A, other than the pixels of A. And A minus B means simply we are only taking the pixels of A and excluding the pixels of B. These are the some set uh, set theory, and also you can see the examples of how the set theory is applied on the images. So here is also A, this is a knot of A. Here we are considering the binary images, okay, where we are applying the morphological operations on the binary image. That's why we are taking the only black and white images here. So here is the black is represented as 0 and white is represented as 1. So when we apply the NOT operation on the object A, this is the output of this. At the same time, A and B, this is the the shaded area is the object, and B here is also shaded area in the object. This is the one image which is consists of the object at the this place. So when we apply the AND operation of both images, then you will get the output as like this. When we apply the OR operation, you will get the output as like this. Means we are taking union. Here is applying the union, and exclusive OR is mutual exclusion. So where the common point is applied, and also NOT of AND, there is a complement of A. So these are some representations of set theory where we are applying the images. So and also we have additional properties. Additional properties here is a reflection. Reflection of the set. So here is a reflection is a set B about its origin, and which is denoted by B is defined as B cap. So here a B cap is equal to B hat. We can call it as a B hat. Okay, means what? The structuring element have its origin. Simply we are reflecting, means we are multiplying the elements with the minus, so that it will simply reflected its with different. Okay, if the set A, suppose I am taking the example a set A which consists of 0, 1, 1 like this. If I apply the A reflection, you will get the -1. Simply multiply these elements with the -1. This is the reflection of A. Now you will get the clear idea what is a reflection. Okay, you can see the examples here how the reflection is applied on the image. So this is the origin. So the dot is represented as the origin. Origin is where the pixels are 0, 0. Okay, so simply its B is about its origin. See, the reflection is a set. B is about its origin. So the dot symbol is taken as the origin, and we are reflector. We are multiplying this all the elements with -1, so that you will get the reflection of this image. Okay, so here you can see this is the B, and the reflection of the B is like this. And also here this is the B, and this is a reflection of the B. These are some examples where the reflection properties applied on the image. Next we'll go to the translation of the set B by point Z is equal Z1 and Z2 denoted by, which is a representation of the translation. So how the translation applied on the image with the help of the set theory. So these are the images. Simply we are translating this point to some other point. How the image is translated from one position to the other position. So here this is the actual elements which belongs to the B, and we are adding some constant to the B. Which position you want to translate? Here is a Z1 and Z2 are the position where we want to translate. So we are adding the current pixel with the translated position, so that the image will be translated to the next position. What are the preliminaries? Next one is what are the functions which is applied on the image. So here we are applying the erosion and the dilation. What does it mean, the erosion and dilation? So these are the important properties in the morphological operations. So previously we have seen the set theory. Next, how the set theory is applied on the image. So these are some basic operations which is applied on, these are core operations applied on the images. So what does it mean, the erosion? Erosion is to shrink an object into the smaller size, and the dilation is which will enlarge the object along its boundary. So when we combine those two, we have the opening and the closing. These are the four basic operations which is used in the morphological image processing. So we'll see one by one. here you can see binary image is represented in terms of zeros and one. 0 is a white and 1 is a black. So for foreground we'll use the white and the background will use the black. And also we have the different grayscale image. So we use only either binary image or grayscale image, which is we can apply the morphological operations on binary image as well as grayscale image. And what does it mean, the erosion? Erosion is a morphological operation that shrinks or erode the boundaries of an object's in image. Simply, what is the image? Simply, we are shrinking the image with the help of some mathematical operations. And also, with what is the use of this erosion? Simply, we are decreasing the size of the object. And also, we can remove some noise in the image. So, and next one is the here at each pixel of all the pixels in the structuring element are set to 1 and belong to the foreground, and also corresponding pixels in the output as image is set to 1. Okay, so here is the erosion is useful for removing small details or noise. Okay, that this is the main application of the erosion. And also this is a representation of the erosion. So this symbol is represented as a erosion by B. Means what? Here B is the structuring element and A is the image. So with the help of the structuring element is moving across the image, and when the match occurs or when the elements present in the structuring element is presented in the A, then we can consider, otherwise we don't consider. Okay, and here is the B of Z. It is the representation where B of Z is the translation position. Actually, this is a representation of the translation position, and which is belongs to the capital A. A is the image and B is the structuring element. Okay, here you can see where A is a set of foreground pixels and B is the structuring element and Z is the foreground values of ones, because here we are identifying the shapes in the image. Okay, so to distinguish the shapes of the image, foreground and background, we are using some rules. For all the foreground we are taking as a ones, and all the background of the information in the image as taking as a 0. So we are applying operations on the foreground of the image. Okay, so here this equation indicates that the erosion A of A by B is set of all the points in Z such that B is translated by the position Z, which is contained in the A. Okay, and next one is, you can see here is the one more we can apply the erosion on the B. Here I is the image and B is the structuring element. Okay, how the foreground and background are deviated from the image. See, this is the example I am considering. You can see this is the image. This entire part is the image. So what I am taking here, this is the image which consists the object. So object is shaded here and the background is keep it as same. Means it is a black white. Okay, we can consider only the foreground. This is the object. So here I am applying the erosion operation on this object. Okay, this is the B. B is the structuring element. The structuring element is applied on the image. Okay, so means what? The structuring element moving across the image, when the any object, this dot is called as the center of the structuring element. This structuring element is placed on the of this shaded area. Then if all the pixels in the structuring element must be matched with the image, then only will consider, otherwise we don't consider. Okay, likewise we'll move the structuring element across the image. Here shrinking the image. See, the actual size of the image is like this. After applying the dilation, the size, this is the image size. Once we apply the dilation, the image size will be shrunken. Okay, this is the representation of the dilation operation. So next one is, you can see how the structuring element, these are the images represented in terms of pixels, and the white pixels are the background and the shaded dark pixels are the foreground, and this is the structuring element. The structuring element may be any shape. It may be the circle, or it may be the rectangle. It may be the line. Okay, it is nothing but the some pattern. So the pattern which is finding in the image, if the pattern is matched with the image, then you can consider. Otherwise, we don't consider. Okay. So simply this structuring element is placed in this area. So there is no match because these pixels are not presented here and also not here. Likewise, we are moving the structuring element row by row. There you can find here. So this is the place you can find the structuring element. So that will add the pixel here. Otherwise, we don't add the pixel here. Likewise, we are placing the structuring element and will move across the entire image. Then after applying the erosion, so the result will be like this. Here is the result here, and after applying the erosion, the image pixels will be shrunken. This is the result of the erosion, and here you can see the example. So here is a example, a pixel which is the size of 486 by 486. This is a binary image because binary image is represented only in terms of black and white, and after that the structuring element, the size of the structuring element is 11 by 11. When we apply the 11 by 11 size structuring element on the image, the result will be like this. When we apply the structuring element, the size is 15 by 15. You can remove the noise. Here you can see, first you can the string and size of the image will be shrinked, and we are removing some parts of the image. Here is also you can remove the some data in the image. Once the structuring element is increasing, most of the border lines will be removed. Okay, these are the results. As the structuring element size increases, you can lose the information or you can shrinken the data in the image. And what does it mean, the dilation? Okay, so the best example of the dilation is it will enlarge the pixels information in the image. Means what? When a ink which is spread on the paper, means when the ink pouring placed on the image, simply it is spreading. That is nothing but the dilation, means increasing the pixels, and the erosion means shrinking, like a sand dunes under the wind. Okay, means it will close and strengthen the pixels. Here we are enlarging the pixels. Okay, so these are the two important operations we are using in the dilation. So same thing, but here is the dilation is increasing the or improving the pixels. So applications of the dilation here is filling the small gaps or holes in the image, or joining or broken and disconnected parts of the image. So here we can filling the small gaps. So there is a gaps in the objects. So here is a shape which is shapes which are present in the image. So but there is some gaps in the object. So I want to fill that object. So with the help of the dilation, you can fill those gaps in the image. So, and the representation of the dilation is, this is the dilation symbol. So here is A dilated by B. So how the dilation is applied? Because all the elements, if any element in the structuring element is mapped with the image, simply you can consider. In previous section, only all the elements in the structuring element must be mapped with the object. Then only you can apply the erosion. Here, only any single element present in the structuring element is mapped with the image, then you can consider, you can apply the dilation. There you can consider the elements. So this is the example of the dilation. So here you can see, this is the image which is having the foreground. This is the foreground and this is the background, and the size of the foreground is d by d, and here d by 4 and d by 4. This is the structuring element of the we are applying the structuring element for the probe on the image. So here B cap, the size of the structuring element is d by 4. Here is a d and the structuring element is the d by 4. Once we apply the dilation, what does it mean, the dilation? The elements which is present in the structuring element is mapped with the any element which is mapped in the object, simply you can consider those pixels. Otherwise, we are considering the one pixel in the structuring element is mapped with the image, so that you can consider those pixels. Okay, this dot is the center of the or origin. We can call it as the origin of the structuring element. So after applying the dilation operation on the image size will be enlarged or improved. So the image size will be increased here. So the actual size of the object is like this. Once apply the dilation on the image, the size will become like d by 8. Okay, so these are the results of the dilation. Even this dilation is applied on the OCR, optical character recognition. There the initial size is like this. Once the apply the dilation on this image, so the size of the these alphabets will be increased. So this is the one application of the dilation. See, this same example previously we have seen, but here the operation is the dilation. So this is the structuring element, and this is the object, and these are the background pixels. Once we apply this structuring element on the image, the result will be, you can see, actual original image is like this. Once the dilation is applied, here the size of the image will be increased. So what is the erosion and dilation versus? Here you can see the main points. Erosion, which shrinks or thins the object in the binary image, which will shrink the image and also removes image components and eroded away the boundaries of region of the foreground pixels. And the dilation, which grows or thickens the object in a binary image and also will bridging the gaps, and also will fill the small holes of sufficiently in the small size. So and also this erosion and dilation are the duals of each other. Means you can applying the erosion and apply the complement, or you can individually complemented the A complement and B reflection and then apply the dilation. So these are the dual in nature. Both will get the same results. Now, what are the two other important morphological operations? But the single dilation cannot remove the noise, and even single erosion is also cannot remove the entire noise. So we are taking the combination of both dilation and erosion to remove the noise as well as to increase the pixels of the information. For that, we are using combination of these two operations on the image. So we have opening process and as well as closing process. So the input image, if you apply the opening operation on the image, means what? First you have to apply the erosion process, then apply the dilation process. For the closing process, first you have to apply the dilation process, then apply the erosion process. So what is the opening and closing? So what is the opening? As we seen, opening is the combination of erosion followed by dilation. So erosion is nothing but, so first you have to shrink the image, then enlarge the pixels. Okay, so it involves applying the erosion operation to the input image to remove small objects or the details, followed by the dilation operation which restores the remaining objects. First we are removing the unnecessary data, then you can enlarge the remaining object. Okay, and here is also we are using the structuring element for the opening. So determine the size and shape of the object to be removed. So opening is where we can use the opening operation, mainly used for the smoothing the contours of objects, means object boundaries. To smooth the object boundaries, you can use the opening operation, and also separating connected objects. So I want to separate the objects which is already connected, but with the help of the opening you can separate those two objects, and also you can remove the small holes or gaps in the object. If there any unnecessary information in the object, so to remove that information in the object, you can use the opening operation. And also closing. Closing is the opposite of operation. Previously, first we have applied the erosion, then followed by the dilation. Here we are, first we have to apply the dilation and followed by the erosion. Dilation is growing the object's pixel information. After that, you can erode it. You can remove the pixels. So it involves the applying dilation operations in the input image to fill the small holes or gaps in the object. Okay, and also followed by the erosion. There you can restore the objects of the original size. Here is also we are using the structuring element with the to fill the shape as well as the size of the holes in the gaps or gaps to be filled. So where the closing operation is used in the image processing. So here we can connecting broken or disconnected parts of the object. Previously, to separate the two objects, there you can use the opening. Here you can disconnect the objects, you can use the closing. Simply the opposite of the opening is the closing. And both operations are useful based on the application. Based on our requirement, you can use the either opening operation or the closing operation. So these are the representation of the opening and closing operation. So these are the symbols. So A opened by B. So this is months. First you have to apply the erosion, then apply the dilation. So first you have to apply the structuring element B, which is eroded with the A. Then the result will be applied after getting the image. So again apply the structuring element B with the dilation. Okay, first you have to apply the erosion, then apply the dilation. This is the representation of A opening of B. And next one is the closing operation. Closing is the dotted the circle with the filled circle. Here is the circle with the empty circle. Okay, these are some representation of opening operation as well as the closing operation. So the opening operation here is first A dilation with B, then apply the erosion operation. Okay, the opposite of the opening is the closing operation. See how the opening operation is helpful in the morphological image processing. So this is the image which consists of the foreground as well as background. So the background is a common. There is no important information in the background, only foreground where the objects are present. Okay, so that part is shaded here. This is the object is in the shape like this. Okay, and B is the structuring element. So with the help of the B, we are probing the entire object here. And here is the operation is the opening. Opening means what? First we have to apply the erosion. Erosion means simply disconnecting. That's why once this is the structuring element which is move across the entire image, then if there is no match here, that's why it is disconnected. Then you have to smooth the image, means you have to increase the pixels information. That's why the edges will become like this. Okay, so this is the application of the opening, A opening of B. Next one is the closing operation. Closing means increasing the pixel information. First you have to apply the dilation, then erosion. Okay, so first we have to apply the dilation, means the pixel values actual background same image I am considering here, but the operation is the closing operation. Here we are taking the structuring element, and also the structuring element is placed on the image, and image is placed on the structuring element is placed on the image. Once there is a single element is present on the image, will consider the pixels of the image. Okay, and then we have to apply the closing operation. So first closing operation which followed by the erosion and also dilation. So this is a vice versa. Previously first apply the erosion, then dilation. Here we apply the dilation, then erosion. So these are the some operations, opening and closing operation, same thing. So this is the image, how the operations are applied on the opening as well as the closing. So if it is the opening, This is the opening operation and also this is the closing operation. How the output is connected as well as the disconnected. So first we have applied the erosion. A eroded B means we are shrinking the image. Then we are applying the dilated. And the closing operation, this is the closing operation. Here A dilated B, then applied the erosion. So these are the different outputs, outputs you are getting with the opening and the closing operations. And also both opening and closing also duality in nature. Okay, so you can take the A opening and B and take the complement. You will get the same result with the A complement closing B B reflection. Okay, this is the dual in nature. So these are the some applications of opening and closing. Here is the segmented. This is the input segmentation of the output image that is considered as the input for the morphological operations. So here you can see some noise is present in the image. So to remove the noise, we are applying the morphological operation, and also you will get the clear information of the fingerprints after applying the opening operation. So here also we are applying the dilation operations and the closing operations. This is the output of the image segment. Here is the input. After applying all these, you will get the clear information of the image. So you can see what are the different, how the different operations will change the image. So here the input image. If apply the erosion on the image will be shrinked. That's why the image looks like the original image. The size will be reduced here. And after applying the erosion, if you apply the dilation, so the shape will be increasing here. Actual original information is here. The original object size is here. Once you apply the dilation, the pixel values will be increased. And here opening is nothing but it is removing the noise in the image. So here is the there is some dots are present in the image. To remove the noise in the image, our structuring elements is the dots. So to remove the noise in the image, first you have to apply the erosion, then the dilation, so that you can remove the noise in the image. And the closing operation is useful for remove the noise or holes in the object. You can see here is a noise present in the image, here is a noise present in the object. So these are some slight difference in the opening and closing. When the noise removed in the entire image, you can apply the operation of opening. If the noise present in the object, you can apply the closing operation. These are the different applications used in the different purpose. And you can compare comparison between the opening and closing. So opening is a process. First erosion operation is performed, then the dilation operation is performed. And closing is a process which first we have to apply the dilation operation is performed, then the erosion operation is performed. And the opening operation performed the union of all the translations of B that fit entirely within the A. Means what? The entire translations of A with the B. And the closing operation is performed on the A and B is the complement of the union of all the translations of B and that do not fit entirely within the A. And also here you can opening operation performed A and B is represented as this is a symbol of the A opening of B, and this is the closing operation, that is the filled circle. And opening is used for the smoothing and the closing is removal of the some noise in the image. These are some differences or comparisons between the opening and closing operations. Now I am going to conclude the session. In this we have covered the what is the morphology and how the morphological image processing is used in the image processing. There we have covered the basic operations of the morphological image processing. So we are using the mathematical operations, that is a set theory. With the help of the set theory, we are applying the morphological operations on the image. So we learn the erosion, dilation, and with the combination of the erosion and dilation, we have two more operations, that is the opening and closing. So you will have clear idea of all these. That is about the today's session. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.